Okay, so in today's video, we are going to discuss our new topic, not chapter, but new topic, which is valence bond theory, which simply means VBT. And at a lot of places, you will see VBT word instead of valence bond theory. So this means valence bond theory. Okay, so what exactly is this theory, or what is this telling? So this is telling overlapping of atomic orbitals over atomic orbitals. Okay, then we have like overlapping. How? Let me just make it. So if I'm just taking this as a, oh god, I'm just taking this as a circle, then this will get overlapped, they will combine. If we just take our hands and we are making them together by shaking or combining it, this means they are forming overlapping between them. Overlapping is there. So if I'm just taking one, then I'm taking second, this both together will be having overlapping between them. So valence bond theory exactly just tells about the valence bond theory. Okay, so this was introduced by whom? That's introduced by London and Hitler. In which year they introduced this theory? In 1927. Okay, they introduced this in the 1927, and this theory tells the bonding. What exactly just tells this theory tells? This tells about the bonding in covalent bond. Just because we're discussing the covalent, like theory of covalent bond, so covalent is very important between like the bond which would be, that would be covalent bond between them, and they are telling they would be bonding in covalent bond, or they will just form a bond in covalent molecule. Covalent bonding would be there in the molecule, and by what? By the overlapping. As I just written, by what process? How could it be possible to make like bonding? That would be by overlapping of orbitals, and this only provide basic information, their structure. But this, like, let me just write few statements. Okay, so I just written how like the overlapping of orbitals, which probability, like what does it tell? The electron, like this tell the finding. I can even add finding word, f, finding of electron which are maximum in number in what? They in valence shell. Okay, like the every changing would appear or would be only in the valence shell. If I have the first shell which have 2 electrons, the second which have 8, this means these both are stable. Okay, but what if I've just taken this as a Na, so the third one which is having is 1. Of course this is not stable, just because this needs 7 more, and 7 cannot be given by any other. Okay, so this means this will given to this, will give this to another. Okay, another shell or another element here. If Na is here, then we can even add Cl. This will be given to Cl, just because Cl has 7 electrons in the outermost shell. Okay, so this all changing would appear in the valence shell, of course, just because the change cannot be appear in the 2, just because this is stable. We know the arrangement, we have 2, 8, 8, like that. So 2, 8 is done, then we need 8 again, but here's 1, this means this is unstable. And then covalent bond by overlapping, which comes by what? When just atoms get very close to each other. How? If I have just made a circle, these both circle, let me just add little here. So these both are embedded together, and this one, like this space which I'm just making a marking, is called the overlapping, the known as overlapping. This place, like this space, show the overlapping between them. So atoms comes very close. Of course, if you have 2 atoms, this will come very close, which are covalent.